Redox reactions come in a variety of different formats, one of which is the single displacement or single replacement reaction. In this case, we're going to typically start with an element and some kind of compound. And what we are following here is the element is going to replace one of the ions in the compounds. In this case, the gold will try to replace hydrogen and try to form gold-3 chloride and then release the hydrogen as hydrogen gas. Now, from this reaction, we could predict the potential compounds. We can derive a complete ionic equation, remove the spectator ions, which in this case are the chloride ions, and then be left with the net ionic equation. Of course, we can do all this, but we still haven't answered, will this reaction actually occur? And one way to do that is to do the reaction, and the answer is it will not occur. And the other way to do that is using the activity series, which is on the side here. It lists a lot of the elements in order of their activity. Whichever one is more active has the ability to replace the lesser active elements from their compounds. So in this case, hydrogen is in its compound and gold is coming in to replace it. But hydrogen is more reactive than gold, so hydrogen will hold on to its partner and not allow gold to interfere. So will this reaction occur? The answer is it will not. And so this is good news for anyone who has gold jewelry and is working with any kind of acid, specifically hydrochloric acid. It's not going to dissolve. So you can keep wearing that jewelry. The activity series is a list of metals, and it includes hydrogen in the sequence, and it puts it in order of increasing ease of oxidation, which one is oxidized easier. And so in this reaction, the question is, will zinc replace copper from its compounds? And then we checked, zinc is up here and copper is down here. Zinc will try to replace copper. Will it succeed? The answer is yes. Now, would it happen the other way? Would copper be able to replace zinc? And the answer is no, and that is when we say there is no reaction. We can use the same argument using the information on the table here to determine whether these reactions will occur or not. So will cobalt replace barium? Well, if cobalt is here and barium is here, then cobalt will not succeed in replacing barium. Next, will tin succeed in replacing copper? Well, tin is here and copper is here. Will tin succeed in replacing copper? The answer is yes. And then finally, would silver replace sodium? It has to go up and it will not happen, so there will be no reaction here. Similar to one of the questions before, will this reaction proceed? Will silver succeed in replacing copper? And the answer is it will not, because copper is the more active of the two metals. In all previous examples, we were looking at the molecular equation. Now in this problem, we're going to look at the net ionic equations here. And so all the anions that are simply spectators of the chemical reactions for single displacement are going to be removed. One indicator of which one is trying to do the replacing is in the indicated charges. So whichever one is in the zero oxidation state, that is the element trying to replace. And whichever one has a charge, it typically indicates that it is an ion that is coming from an ionic compound from somewhere else. And so that charge, just like the wedding ring on a person, says, I'm sorry, I'm coupled. And it's a matter of attraction between the newly single or the single element and the counterbalancing anion that determines whether the reaction will proceed or not. So in this case, will nickel succeed in replacing hydrogen? And we know that nickel is trying to do the disruption because it carries that zero oxidation state. So this is nickel, this is hydrogen. Nickel is trying to kick out hydrogen. Will it succeed? And the answer is yes. And then we do the same determination in the following problems. Here we have platinum in the zero oxidation state and hydrogen with a charge, so with a partner. Platinum will try to replace hydrogen. It is not going to succeed. In the next case, we see that tin has the partner and hydrogen is in its elemental state. So hydrogen is going to try to replace tin, and that is not happening. In the next case, nickel has the partner and gold is trying to do the replacing because gold is single and it has that zero oxidation state. This is gold and we're looking at nickel right here. So gold will try to replace nickel, not happening. And in the final problem, copper has the zero oxidation state. So copper is the single person trying to break up zinc and its partner. The zinc is here, copper is here, and copper will try to replace zinc. Well, that is not happening either. So the correct answer here is option A. In this question, we simply have to remember everything that we learned about the different types of chemical reactions and identify which type fits best. So here we have a soluble ionic compound reacting with another soluble ionic compound to produce an insoluble and a soluble product. And if we remember correctly, then two soluble materials reacting to produce an insoluble product is called a precipitation reaction. In this setup, we have three reactions that we need to classify. So in the first one, we have a compound, an ionic compound, reacting with an element. And if memory serves me well, then if you take a silver ring and put it in water, it will not dissolve. So this single displacement reaction cannot be a precipitation reaction, even though the silver chloride that forms is going to be a solid. So is copper. This is another solid. So it does not meet the criteria for a precipitation reaction. However, it does meet the criteria for a redox process. So options A and options D would be correct. Let's see how we can follow that. Sodium hydroxide is a base because it contains hydroxide. Sulfuric acid is an acid, as the name indicates, but it's also an acid because it starts with hydrogen. And when the two combine, water is formed and a salt is formed. So this is an acid-base reaction. So here, option D is correct, and this is incorrect. Then finally, copper 2 chloride reacts with sodium sulfide to produce sodium chloride and copper 2 sulfide. Copper 2 sulfide is insoluble, and everything else in this reaction is soluble. So if we start with 2 soluble materials and we produce at least 1 insoluble, then we have a precipitation reaction, and the correct answer choice is option D.